Hi, everybody. I thought that you might like to have a couple more examples of arithmetic and the other bases. So I thought I would show you one multiplication and one division. And I thought that we could do base 6. That's a base that we didn't do in the lecture. So as you can see, I've already started my base 6 multiplication table. I'm going to fill that in first and kind of talk you through it. And then we'll do this multiplication problem, and then we'll do a division problem. So when I started thinking about this, I was thinking about how in base 5, I'm always encouraging you to think of it as pennies, nickels, and quarters, right? Because the first 3 place values in base 5, working from the right, are 1s, 5s, and 25s, right? 1, 5, and 5 squared. So I thought, well, let's see, is there something like that for base 6? Something that you could think of as 1s, 6s, and 36s. And what I thought of was soda cans. Soda cans come in 6-packs. And if you go to Costco, they also come in 36-packs. So that's how I'm going to think of this. So as I fill in my multiplication table, first of all, 1 times anything is just itself. So that's easy. We can fill that in. And then remember, since multiplication is commutative, no matter what base you're in, this table is going to be symmetric. So whenever we fill in a row, we've also got a column. Okay. So the next thing I'm going to look at is 2 times 2. 2 cans times 2 would just be 4 cans. Remember, in base 6, you only have the digits 0 through 5. Now, 2 cans times 3 would be 6 cans, which I can group together as 1 6-pack and 0 loose cans. So in base 6, 2 times 3 is 1, 0. 2 cans times 4 would be 8 cans, which would be 1 6-pack and 2 loose cans. And then 2 cans times 5 would be 10 cans, which is a 6-pack and 4 loose cans. Okay. So now that I have that row, I also have the corresponding column. Now we move to 3. 3 cans times 3 would be 9 cans, which is 1 6-pack and 3 loose cans. 3 cans times 4 is 12 cans, which is 2 6-packs and 0 loose cans. 3 cans times 5 is 15 cans, which is 2 6-packs and 3 loose cans. All right, so I hope this is helpful. In any base, if you can think of something like that, even if you have to make it up, it could be helpful. Okay, so not a whole lot left to do. 4 cans times 4 would be 16 cans, which is 2 6-packs and 4 loose cans. 4 cans times 5 is 20 cans, which is 3 6-packs and 2 loose cans. And finally, 5 cans times 5 would be 25 cans, which is 4 6-packs and 1 loose can. All right, so now I'm ready to do my multiplication problem. So starting with the 3 here on the right, 3 times 3 is 9, which in base 6 is written 1 3. So I put a 3 there, carry the 1. 3 times 5 in base 6 is 2 3. 2 3 plus 1 is 2 4. Carry the 2. And then 3 times 1 is 3. 3 plus 2 is 5. All right, and now I can take a little shortcut because I'm multiplying by 3 again. So that's just going to give me the same answer shifted over. And now I get into my addition. I am adding in base 6. So I bring down the 3. 4 cans plus 3 cans would be 7 cans, which is a 6-pack and 1 loose can. 1 plus 5 is 6, which is a 6-pack. That's 1, 0. Plus 4 is 1, 4. And then got to be careful here. 1 plus 5 is 6 cans, which is 1 6-pack and 0 loose cans. All right, so in base 6, 153 times 3, 3 gives you 1, 0, 4, 1, 3. All right, so now I'm ready to move on to the division problem. I would like to keep my multiplication table though, and the only way I know how to make that happen is to just erase what I have over here. Okay, so the division problem that I cooked up was, and this again is base 6, 3, 4 into 5, 0, oops, 4, 3. Okay, now I will admit, even I find long division in other bases to be kind of tricky. Really got to keep on your toes. So the first thing I'm going to do is try to figure out how many times does 3, 4 go into 5, 0. So you can think of that as, let's say you have 5 6-packs of Diet Coke, and you need to take three 6-packs and 4 loose cans. How many times would you be able to do that? Well, you would only be able to do it one time, right? Okay. So 1 times 3, 4 is 3, 4. Now I have to do the subtraction in base 6. So I can't take 4 from 0. So I'm going to have to take one of these and put it over here. 4 minus 3 is 1. And then a 6-pack minus 4 loose cans would be 2 loose cans. Okay. So now I'm going to bring down the 4. And this is where it really gets tricky. So now I have to think about how many times does 3, 4 go into 1, 2, 4 in base 6. Well, if you think about what you do in base 10 in a situation like this, at least what I do is, if I don't want to think about how many times does 34 go into 124, you can kind of get a rough estimate by looking at how many times does 3 go into 1, 2. So if I look at my multiplication table, in the 3 row, 3 times 2 is 1, 0. 3 times 3 is 1, 3. So my best guess for how many times 3 goes into, actually it's not a guess, 3 goes into 1, 2, 2 times, okay? So that might be my best guess for how many times 3, 4 goes into 1, 2, 4. So I'm just going to try it. And how I'll know whether it works or not, first of all, when I do 3, 4 times 2, and I write that answer down here, if I get a number that's bigger than 1, 2, 4, then I know something's wrong. But if I get a number that's too small, and what do I mean by too small? Well, it would mean that when I subtract these two numbers, I would get something here that's 3 here. That's 3, 4 or bigger. Okay, so let's try it. 2 times 4 in base 6. Remember, that's 2 cans times 4 is 8 cans, which is a 1 6-pack and 2 leftover cans. So here's the 2 leftover cans, carry the 6-pack. And then 2 times 3 is 1, 0. Plus 1 is 1, 1. All right, does your head hurt yet? 1, 2, 4 minus 1, 2 is 1, 2. Bring down the 3, and I think I just got lucky again. Oh, so let me just say that at the point where I had the 1, 2 here, I know that I did good with this 2 up here, all right? 1, 2 is less than 3, 4, all right? And that's what I need my remainder to be. And then I was about to say I got lucky because, so we figured out that 3, 4 goes into 1, 2, 4 2 times. Well, I think 3, 4 is also going to go into 1, 2, 3 2 times. And we even already know that 2 times 3, 4 is 1, 1, 2. And that's going to give me 1, 1. And that's going to be my remainder. So in base 6, when I divide 5043 by 3, 4, I get 1, 2, 2 with a remainder of 1, 1. All right, so I hope this has been helpful. I know that the different bases are tricky, believe me. It takes lots and lots of practice. So talk to you soon.